I'm Nina Gregory, and I'll be moderating this conversation, Frontiers of AI Learning Systems, Research, Models, and Methods, with Madhavi Sevak. She is a distinguished research engineer on Google's DeepMind. We have a lot to discuss. I want to try to keep some time for questions, and we'll just jump in. Madhavi, you've been at Google for almost 15 years. You've seen a lot of innovation and transformation in that time. Can you give us a little thumbnail about how DeepMind fits into the timeline at Google of its products that you've worked on and seen?
Yeah, absolutely. I think Google has been at the forefront of AI almost its entire life cycle. I mean, we adopted traditional AI methods in everything from search and ads to GCP, like all of our core businesses. We used it for recommendation systems for YouTube. You know, we've always leaned into AI tools. And Google DeepMind joined Google, you know, was it 8 years ago now? Roughly, I think. Or 10 years ago, you know, not so long ago in Google's 20 years lifespan. And DeepMind has revolutionized how we do, you know, games. To start with, DQN, AlphaGo, these were some of the early things that Google DeepMind did. Google DeepMind and Brain together also came up with, for instance, the Transformers paper, which led to this revolution of AI that we sit in now. And then all the way to now, where we are creating models that are at the forefront of the Pareto frontier. They are the best for their quality at the cost that they are. They're also the best at quality, you know, period. And also in terms of latency, we have some of the best and fastest models available in the market today. So Google DeepMind, I think Demis likes to say, is kind of the engine room of Google, powering a lot of the things in the back end. And you know, this is something I'm very excited to be part of.
Yeah, yeah. And you know, part of what you're doing is helping Google itself adopt AI. Can you talk a little bit about how that's gone?
Yeah, so Google has so many billion user plus products, and I don't think that we've done enough to have LLMs revolutionize all of those products to the extent that we could have done yet. And so I think there's a lot of opportunity here, and this is something I'm working with the rest of the product areas on. I think this is very exciting because, again, it depends on what you're trying to do, right? Let's say you're in Workspace, you're using Gmail, you're commuting. For instance, Gmail can provide an agent to you that can help you, you know, answer your chat messages, look through your email, add events to calendar, you know, kind of sort out your life while you're driving. All of this in a conversation. Yes.
Yeah. How far away is that?
From a technical point of view, not so far away. I think at this point it's execution, because in my belief is that the models are now intelligent enough to do this. We don't even have to wait for the models to become more intelligent to provide 80% of the use cases that, you know, humans want to use models for today. So I actually think that this is now a matter of execution, not a matter of research.
Right, right. That's fascinating. You think about the suite of Google products and how, I mean, it seems like it might be easier to build an agentic product over Google's suite first and foremost, and then whatever else outside of that. But Google DeepMind's motto is build AI responsibly to benefit humanity. What does this mean, and where does this come into play practically in your work?
Yeah, so practically, I don't know how many of you have used AI mode in search. I don't know if you have. I mean, raise your hand if you have. Okay, that's actually not bad. You know, I think typically Google needs to do a lot better job explaining what our offering is, and that's something where, you know, we need to get better at. But for instance, I think the AI mode is something that is very compelling as a product, right? So let's say we build AI models, and I'm, you know, involved with model creation, model development as well. But how do we use these models in such a way that end users can get the benefit of these models? So let's say with AI mode, you're trying to plan a vacation, you're looking up stocks, you know, you're trying to figure out what were the last, you know, did I buy that bath mat that I intended to buy, or did I not? Why should we need to go to all these different services when Google has access to both your private data, if you allow it to, as well as, you know, the web data and shopping data, because we have so many relationships with merchants. I think we want to provide an experience where we can bring all this together in such a way that we can send the right clicks out to publishers, the right clicks out to merchants if you're trying to buy something, or get information from your own private corpus in such a way that we can answer questions about you to you, again, in a way where it's privacy safe and it's compliant, and you've explicitly given this permission. This is something we want to do. And again, I think this is a matter of execution now, not a matter of model intelligence, because now, as of this moment, we have models that are smart enough internally that can absolutely do this.
So I can say, go find the book that that Madhavi recommended. I can't remember if she emailed it to me or if it was in my text messages. Would it be able to then go outside Google into my iPhone text messages and then go to Amazon or my library app and buy the book?
Again, so technically, yes, right? Because all this is a series of tool calls. So if you tell the model, okay, let's take an example. So I live in San Francisco. Find me all the houses in my neighborhood that sold recently and the price that they sold at, and email this to me. This is a matter of looking up like Zillow, Trulia, getting this information, collating it, looking up your zip code. This is something that we have in Chrome autofill, putting this together and then emailing you. So the tools you called were, either API calls or, you navigated websites for Trulia, Zillow, et cetera. We looked up your, 94132, what is it, zip code, and then we called the Gmail tool and we emailed you. This is 100% technically possible today. I mean, any of you can develop this probably very quickly, given all of the coding agents that we have available externally. I mean, and also Google is going to play in this space. But the point is that I think that across companies right now in the whole industry, it is a matter of really solid execution, and most use cases are not gated by research. Like most of the things we've spoken about today, the ability to look up, for instance, my photos and, say, hey, I was reading that book, it had this quote, what book was it? It should be able to do this, because I take photos of books I read and, I highlight things I like. So it should be able to search this and then
take photos of books you read?
Yeah, like pages that are interesting to me.
Yeah. That's useful. I like that.
And I send them to my sister. My sister's like.
And then you can always, now we can search it.
Yeah. Right? And also, if you have the Photos app.
Or it's,
yes, PDF, a screenshot, exactly. Because Gemini, for instance, is natively multimodal. And there are a few models in the market, even outside of Google, that have this native multimodality. So you can talk to it. They can look at PDF. They can look at images, videos. They can, you can create embeddings. Pre-create, pre-calculate embeddings based on, a set of images, videos, text, whatever. And then this search can have very little latency. And if you basically do web data ingestion, via search, and then you do private corpus grounding with RAG, this is something that can be orchestrated today. So what I'm very excited about is our ability, and honestly, if it's not Google, it's going to be somebody, but this is going to be a reality for users very soon. So, I'm really excited that this is something that's coming to the market, again, regardless of whether we do it or not, because the models are capable of it.
You mentioned coding agents. Can you talk a little bit about what do engineers think about coding agents?
So this is a good question. I think there's many ways of thinking about it. At least in the circles that I'm in, people are very, very, very excited, because I think vibe coding is something that's here to stay. I think we've talked about real systems architecture, real design, real code, production-ready things. And then obviously we've seen agents fall flat on their face, with deleting folders, with deploying code that's very buggy, with not being production-ready. But I think that there's going to be a paradigm shift where you will farm out tasks and subtasks, and then you will, as a human being, review things more so than you will code things. System architecture is a skill set that's here to stay, because that's where a lot of the deeply technical work will come in. And a lot of the code that we write, I don't know, 80% is boilerplate, 20% is logic, right? So 80% it should just do the scaffolding for you, and then when you're doing the 20% that's logic, even then I think you can work with these code agents and discuss with them. You can do planning. You can do planning with very smart models, and then you can do execution with smaller models of smaller sizes. You can do long-running asynchronous tasks. You can redesign code bases. I mean, I think already we have the ability. So I'll give you an instance of this. So there are a few models on the market, including Gemini, that have super long context. So they have 1 million context windows. And before, let's say, February, we used to see very little use of these long context windows because people didn't really have a use case for them. But now we are seeing so much more traffic, like many X the number of
What are they doing?
code. They're putting in their whole code base and they're saying, refactor this. They're putting their whole code base and saying, fix these bugs, make these features happen. All of this is very useful. And I think that as models evolve, they are going to be trained with longer context windows because now we know this is a very important use case for the market. And I think that models will get even better at using long context to create really compelling code. So yes, agents fall flat on their face. But again, I think this is an evolution of intelligence. And I think in this case, I think model intelligence does need to catch up to the extent where we can trust it for production-ready code. But I don't think it's more than 6 to 12 months behind. And even today, if you do with human-in-the-loop reviews, I think there's a lot you can do with models the way that they are today. Also, I don't know if we've seen all of this, all of us have seen this on Twitter. How many companies now have $1 million run rates with one employee, right? Like we've seen tens of those. This was not possible, let's say like 2 years ago, because just the amount of code you need to write to make an app ready for that is so much, right? But now we're seeing more and more of these use cases.
That's a great segue to Windsurf, which was an IP acquisition at Google on which you led the technical due diligence. Can you tell us about Windsurf?
Yeah, so I think this is a kind of a spicy topic, but Windsurf was a fantastic product. And now we're evolving it. And then obviously Google is going to play in this space. Then Google is going to have a compelling IDE offering. And we want to be able to use our most intelligent models with the best editor and then deploy it because also we have GCP. We're like vertically integrated company, right? We have the whole stack. And so, for instance, today you have companies like Lovable, you have Vercel, Figma to Bolt, whatever else, right? And you're coding on these platforms, and then you're vibe coding a bunch, and then you have to figure out a way to deploy these apps. This is kind of a janky experience today. It's happening, but it's a little bit janky. So what we're hoping is that we can have a really nice offering in this space where you have the ability to choose between the best models, the ability to iterate on this code, and then deploy it on GCP in such a way that it can be productionized. You can have 1 million queries on it without your infrastructure falling flat on its face, and without you having to personally architect that system because, you want to use your expertise and time doing the logic and doing something that's differentiated. Worrying about whether or not you can get the infrastructure to serve a bunch of queries is not a great use of your time.
DeepMind also has an ability to problem solve. It brought together Google Brain and DeepMind, and I think that helped in that. Specifically, I want to hear about what it might mean to the field of mathematics in terms of finding new answers and new questions.
Yeah, so I think we published a paper on this recently, but we have this thing called co-scientist, and we also have these math-specific models, and we are now able to. Okay, so take a step back. 2 years ago, we had models, and we had ChatGPT, and we had our own models too, and they were just kind of predicting tokens from left to right. That's all an LLM is. It's just a next token prediction mechanism, right? So if you're trying to do something very complicated, you're trying to do maths, physics, chemistry, whatever, right? Nobody is going, human beings who are experts, who have PhDs, who teach at Stanford are not going left to right. They're generating hypotheses, they're iterating on them, they're going back and forth, they're hitting dead ends, they're rewinding a little bit, and then they're going back into the problem. So when models were just left to right, we kind of hamstrung them a little bit because they made mistakes, they didn't have the ability to do all of this. A lot of the models for us, for instance, we had this thing called Deep Think, which we gave to, Ethan Mollick, a bunch of really smart math people, and they used it on really interesting proofs and even new ideas that had not been discovered before, because they are able to kind of generate multiple hypotheses at once, rank them, and the models are smart enough to know when they're not being smart. So they can critique their own work, they can iterate on these, given enough compute and time, they can generate completely new proofs to algorithms that are more efficient. And I think we've published a couple of these examples. And I know there are a couple of millennial problems. Is it the millennial problem? What are the millennium problems? Whatever, there's 3 of them that we're trying to attempt to solve now. And I'm pretty sure we will be able to do them. Also, we published this thing called co-scientist, which basically does the same thing in the fields of physics, science, biology, chemistry. I think for biology, we obviously have AlphaFold for chemistry and biology, but we're also doing, this co-scientist thing. And, we have a
We're
bunch
also doing AlphaFold. I mean,
there's a lot of work going on at Deep.
that's incredible too. Do you ever interface with the AlphaFold people?
Yeah, I mean, I know some of, I know John Jumper, for instance, but I don't work at all with AlphaFold.
But it's pretty cool.
Yeah, I can refer you to someone who knows more about this topic.
What applications of the model do you see coming?
So I think we've talked about some of them. Some of the things I'm most interested in are these agentic workflows that we are going to orchestrate. I think if you play this out 1 year or 2 years, we're just going to have one agent that's smart enough to do all of your activities, right? And you're not going to worry about size of task, complexity of task, class of task. You're just going to give it tasks, whether it's synchronous or asynchronous. It will be smart enough to determine how to execute it. You will give it feedback, and then it will be able to do these things for you. I think this is true like 1 to 2 years from now. Between now and then, there's going to be many iterations and revisions of this, and we're going to see different levels of execution. And I think this is the evolution I'm actually very excited about, even the ones that are more nascent, because I think there's a lot to learn. And I think models will learn a lot from how agents are using the model. And I think that there will be a flywheel, and we will have smarter models as a result of a lot of these agents that
Fascinating.
are going to be in the industry.
What are some of the early agents that you see, and then some of the more, complicated or long-term hopeful use cases?
So Google came up with deep research, right, first, and then we had a bunch of other folks in the industry adopt it as well. But deep research is an example of an agent. So again, because ChatGPT was the first company to go out and kind of use LLMs in a user-friendly way, people got very accustomed to the really quick back and forth with the LLM. But this barely touches upon what the model's intelligence has to offer. Similar to if you only ever chatted with me and I never actually got to do any work, I don't think you would ever experience the kind of frontier of my intelligence. And so, for instance, deep research is one example of this, right? You can do long-running tasks, and this is something that now a lot of people have adopted, but this is in its nascency.
What is a long-running task? What's an example?
Like it could take 3 hours. It could take a day. I don't know if you're asking someone to code an entire product for you. You give it a whole, you write a PRD. You don't even write it. You kind of just like talk to the model and you say, this is what I want to build, and it takes 6 hours to build it. I think that's reasonable, right? This idea of synchronicity, where you ask something, I respond to you. You ask something, I respond to you, is not necessarily the only way to interact with LLMs, but it is one way in which we are now interacting a lot with LLMs. So I think that we as humans are going to get more accustomed to asynchronous, long-running tasks, tasks of different complexity. We're not going to wait for the agent to come back to us immediately. So deep research is one very small example where it takes like 4 minutes to answer, and it's going to do a bunch of research. It's going to look at a bunch of documents. But think about deep research in the context of an enterprise. You have a lot of private data. You don't want to share that with the company that makes the LLM. Sounds good. But you want the LLM to prioritize data that's coming from your own company, right? And you want to chat with this. So this is an example of an enterprise use case where an agent can provide a differentiated something that the company doesn't have today. And then, like I said, if you play this 2 years out, I mean, I don't ever want to look at my email. I don't want to sort through it. I mean, I don't want to interact with like half of the things. Forms. I don't understand why we still fill forms as people. I never want to book an appointment. I don't care.
Yeah.
Honestly, like if they're smart enough, I never want to look at my taxes. I don't care.
Can AI? I mean, yeah. Why not?
Why not?
Why not? Okay.
Invest for me. Like, do not make me interact with things that I'm not interested in. I don't care.
I did take Gemini for a spin. As a journalist, I would never do this in a professional setting, but I thought this might be fun, where I asked Gemini to give me some questions to ask you.
Oh, I do this in a professional setting constantly.
Well, as a journalist, I get paid to think about questions, and so I don't want to outsource
Human in the loop.
Human in the loop.
Critiquing, yeah.
Human in the loop. Okay.
The model.
Okay. Yes. Yes. I started and I said, you know, I said, Madhavi Sevak is a distinguished researcher and research engineer at DeepMind. I'm interviewing her at Stanford. Can you please give me some questions? And it said, based on the search results, her work focuses on developing and applying large language models, particularly the Gemini family. I wish it had said of which I'm a part, to create new types of interface, you know, a little personal, interfaces and AI systems. So I want to get to the, it didn't really give me questions, so I asked it to give me questions.
I'm very vocal on the internet.
I know. This is why I did this, because I couldn't find anything about you. I exhausted all of my, I know. You are hard to report on, my dear.
I'm kind of a recluse typically.
Well, that's why I thought Google might tell me, because you work for Google, and I thought DeepMind type that generates UIs in real time. Yeah? What do you see as the biggest challenge in moving from a fixed UI to a dynamically generated one? And how is this a boring question, or do you guys think this is a good question? You like this? Yeah. Okay.
Let's do it.
So, okay, what do you see as the biggest challenge in moving from a fixed UI to a dynamically generated one? And how is DeepMind addressing the need for a fluid and reliable user experience?
Okay, so number one, DeepMind doesn't do user experience. The people who are building the products have to do user experience. But we will provide you with the hooks to create a user experience that you can curate, because you are, ultimately, you are developing the product, right? We're not providing you with a product. We're providing you with a tool that can help you make an excellent product. So the point of the work I did on the neural operating system, and it's deliberately worse than I think what we can do, because I mean, I think we want to have a product in this field as well, but this was kind of a nice prototype. But we have a model called 2.5 Flashlight, and it is incredibly fast. So the latency is really, really good. And the quality is quite good. And one of the things we wanted to show is that this is an operating system that when you look at the video and when you click into it, it just feels like a normal operating system. Yet every single page is being written. The whole code is being written while you click, between the time it clicks and the time it renders, completely taking into account the context of what you have clicked before. So the thing with the models are that they're stochastic, and so when you exit out of a page and you go back in, it's not going to look the same. And obviously this is a pain, like nobody wants to actually make a product that's like this, but the point is to show you the quality of output at the latency at which we offer, because that's one of the things that we are the only lab to do at that level. I think we have one of the best quality for latency trade-off models. And again, I think that people are kind of, they're loving their, benchmarking and all the benchmarks, and who got the best,
That's funny.
However,
I didn't know that term, benchmarking.
Yeah,
that makes it sound like they're actually like lifting weights, but
I mean, they absolutely are.
They're not lifting weights. Okay,
I think that's what weight tuning is, no?
Okay, I want to give you one more Gemini question. This is cheating. It's why I don't do it. It's cheating, okay? And we're humans, but you were the co-author on a technical paper for Gemini 2.5, correct? How come I couldn't find that?
I mean, that's
a skill issue.
No, it's actually like impressive how little I am on the internet.
It is. It is very impressive. Yeah, I didn't actually, have an academic paper. I was searching for things. But from your perspective, what is the most significant? From your perspective, redundant, right? We're asking her. I'm just editing in real time so that you all know why bad question. What is the most significant leap forward with this model family? Do you all find this interesting? The most significant leap forward with this model family?
I mean, we'll have new model families coming out at some point. So, I mean, I'll tell you the most recent leap forward. Okay, so code, visual reasoning. I think those are two I like. Okay, so I mean, it's no secret the Gemini models were not great at coding. Now we are, yay. That was a lot of work. So I'm very proud that Gemini models can code. We will have some announcements in this space very, very soon, and I'm really proud, like really, really proud of how well the models can code, all the way from front-end apps to now actually serious coding as well. So that's one. Two, the native multimodality is something that is really, really good. I don't know how many of you have played with Nano Banana, but it's like an awesome model. You can edit images, it's really, really cool. And think about that functionality being natively available in the model at some point. So for me, that's really exciting. The model's ability to natively see, hear, but not smell, but whatever else, to do everything, like to be a person, to have all the senses that we have, and then to translate them in ways and reason about them in ways that are very interesting. So this is something I'm very excited about.
Cool. Well, I think we're at time. I don't think I left time for. Do we have time for questions? I don't think so. Nobody knows. Okay, so we'll ask no time. Okay. Well, thank you so much.
Thank
If
you,
you
Nina.
have questions, maybe at a cocktail hour, they can come up and ask you. Thank you. This was very interesting. Thank you all.